Bismillahirrahmanirrahim. In this video, I will explain the automatic and the semi-automatic circuit in pneumatic system. So first, automatic circuit is one that continues to work, performing a task over and over again. And a semi-automatic circuit is one that completes a process once it has been started, usually by a human operator. So let's give you an example. Here you can see a double acting cylinder which has two ports, 1 and 2. The name of the cylinder is A. Okay. And A plus means the cylinder will extend to this side, and A minus means it will retract to this side. So in case of semi-automatic, if A plus and A minus just happen once, then this circuit will call the semi-automatic circuit. And for automatic circuit, if A plus and A minus happens in a loop, then it will call automatic circuit. Let's see a problem. So the problem states that a small company that makes spice racks wants to automate some of its production. To begin with, a drilling operation is to be controlled by a pneumatic cylinder. An operator will start the sequence and then the drill will be lowered automatically into the wood. Once the hole has been drilled to the correct depth, the cylinder should automatically instruct ready for the process to start again. So by this statement, we can deduce that this is a semi-automatic circuit. The process won't be happening again and again. The operator will be controlling it. In the picture, you can see a roller trip. I did not discuss the roller trip in any of my videos, so let me explain you that. So in the picture, you can see a roller trip. In the symbol, you can see a 3x2 direction control valve. So this roller trip is nothing but a 3x2 direction control valve, which has a roller trip instead of a button. Here you can see 1, 2, 3. So this is port 1, this is 2, and this is 3. So just imagine here is a spring, and in this side we have a button. Okay. So in the initial position, in this state, 2 and 3 is connected. So 2 and 3 is connected. No component is connected to port 3 because the gas is going into the environment. So it's act like a tank. And 1 will be connected to a pressure port. So if the end of a cylinder rod trips this lever, it pushes down, then this side will get actuated and the compressor gas will go from 1 to 2 and actuating some actuator. If you don't know the cross-sectional area of a 3x2 direction control valve, let me show you. So suppose this is port 2, this is port 3, and this is port 1. Port 1 has compressor. Port 2, I guess, has a cylinder or some actuator. And port 3 is the tank. At initial position, port 2 and 3 is connected. Nothing will happen, nothing will actuate. And here we have a trip lever. So when a cylinder actuates this lever, this button get pushed. These two ports will get blocked and these two will get open. So compressor air will get to the actuator and actuate something. So I hope you understood what a trip lever is. So let's draw this circuit. Suppose this is my pile of wood. This is my drill. And this is my double acting cylinder which have a drill instead of a rod. This is my roller valve. This is my 5x2 DCB to control this double acting cylinder. And this is my 3x2 DCB. It's for the operator to initiate the process. And the connection will be like this. When Operator presses the button, then the drill will go inside. So this side will be connected to the 3x2 DCV. When this double acting cylinder reaches its end position, then it trips this lever. Tripping this lever will actuate the left side of this 3x2 DCV. Then it will actuate this 5x2 DCV to again return to its initial position. Let's simulate this. This left 3x2 DCV will be for the operator. So I'll give push button and spring return. This right side DCV will be the roller valve. We can't directly connect this DCV to the cylinder in this software. Instead, we have to give an identification. Let me show you. So here, double acting cylinder actuating levels. So I have to give a level. Let's make A1. The start position and end position will be same. I'm giving millimeter. Here range showing that 0 to 100 millimeters. I'll start 100 and also end in 100. Okay. So here you can see one identification. I will change this 3x2 DCV to roller lever and spring returned. If I double click this roller lever, then you can see identification. I will give A1. Now let's connect as usual. Let's simulate. Okay. So if I press this button, the cylinder will extend. It will go to A1. The A1 will trip this lever. The left side of this DCV will actuate. It will signal the right side of the 5x2 DCV. Then the cylinder will retract again. Go. See? Let me show you again. As I explained. So this problem is solved. And another thing is that this is a semi-automatic circuit. The operator pushes the button and the sequence happen once. And this is my second problem. Build a circuit for polishing machine. First, let me give you a practical demonstration. Suppose this is my polishing surface. I have a brush here. This brush will brush the surface and the surface will get polished. This brush will be connected to a double acting cylinder. To control this double acting cylinder, I need 5x2 DCV. Now to control this 5x2 DCV, I need two 3x2 DCV. I will make both of these roller valves. Suppose this is cylinder A and the initial position is A0 and the end position is A1. Let me connect this. This right DCV will sense the A0 position. When it senses A0 position, it immediately gives signal to this 5x2 DCV and the cylinder will get extend. The extend position is A1. This left 3x2 DCV will sense the A1 position, then immediately gives signal to this 5x2 DCV. The cylinder again retracts and the process continues. This is a automatic circuit. So let's simulate. I will work with this circuit. I have to change the identification. Now I have another identification which is A0 and this will be millimeter. Start position is 0. End position is also 0. This 3x2 I will change this to roller lever. This roller lever will sense A0 position. Let's simulate. See, works perfectly. Let's see again. Works perfectly. But there is a problem in this circuit. The problem is that the only way to stop this circuit to actually remove the compressor. We don't want that every time we want to start the circuit. So I want to control the initialization and termination of this circuit. I can do that by introducing three additional direction control valves in this circuit. Let me show you. This DCB have pilot operated in both sides. This DCB will have a push button. These two DCB will connected to this upper DCB, and this upper DCB will control the left lever DCB. I will give a text on switch, and this is kill switch. So let's break it down. When operator pushes the on switch, the upper 3x2 DCB will actuate on the left. A signal goes here and actuate this lever valve, and this 5x2 will get actuated and the cylinder extends. When A1 position reached, this A1 plunger will sense the position and give signal to 5x2 DCB and cylinder retracts. If we press the kill switch, then right side will get actuate, no signal to the left lever plunger, and the system will stop. Let's see. Pressing the on switch. Now pressing the kill switch. Okay, works perfectly. So this was an improved solution of our problem. If you don't understand any part, feel free to comment.